Hello, this is Swati Mari and this is a session on how to write Prolog programs, a language that is based on first order logic. Some people believe that Prolog is a dead language, but it is one of the strong and very effective language to represent the knowledge and perform reasoning. The Prolog program can be written in Turbo Prolog editor or one can use Swi-Prolog. The Turbo Prolog editor is an application that was developed for 32-bit operating systems, but you can use DOSBox and one can write programs using Turbo Prolog. The reason why some people prefer Turbo Prolog is one can see how the Prolog program gets executed, the backtracking and the sequence of matching unification. So the knowledge representation and reasoning techniques can be demonstrated using Turbo Prolog, while Swi-Prolog can be done over Linux or one can use online compiler to execute the Swi-Prolog programs. In Turbo Prolog, domains, predicates, clauses and goal, these are the sections wherein domains and goal are optional. The domain section declares variables, predicates declare the relationships, and the clauses uses the declared predicates to represent the information in terms of facts or the rules. In case if the predicates are not written, then they cannot be used in the facts or rules, and in case if they are written in predicates section, then there has to be at least one fact or rule for every declared predicate over here. The goal is how do we execute the program. So when it's optional, then while executing the program we can go on giving different goals. Otherwise, if you want the execution to start from a particular statement, for example displaying menu or creating some graphics, that can be given in the goal section and the program execution would start from those statements. While as in Swi-Prolog, we need not write domains, predicates, clauses, goals as a title, but the program would contain only facts and rules without the clauses title. While writing a Prolog program, as you have seen, the facts and rules are common and compulsory elements. The clauses must end with a period because they are expressing some definite information. The clause would be a predicate with the predicate name and it would contain some arguments. Now typically these predicate names are relationships or verbs which are expressed in the statement, and the arguments do take the form of the main subject and then one or more objects, etc. So here there are some examples of facts represented. Mother Meera, Arya would be read as Meera is mother of Arya. 25 is greater than 20 and Tom's type is cat. So when you have a fact, it can be read into an English statement and English statement can be expressed as a fact or a rule. So to define, a fact is a basic unchanging relationship or property which is expressed in the statement. So Arya is a person is a fact. Meera is Arya's mother is a fact. Or here is an example wherein we can see there are more than one arguments in the statement which is expressing information about a student. So student is a group and one of the instance of that group is Sushil, who's from third year computer engineering and has CGPA of 8.75. Similarly, we can use the distance as a relationship between any two places and the distance in kilometers can be expressed over there. So this is one of the way of representing information in the given statement. So how do we write the facts? Read the statement and identify a relationship in the statement and that would become the predicate name. Identify how many arguments would be required to represent the information in the statement. For example, a student information can depend on various entities, while as a mother information would depend on who's the child and who's the mother, so two entities. Now equal to 2025 or day Wednesday is a single argument information. So accordingly one can identify how many arguments would be required to represent the information in the statement. So here there are certain examples. John is a man or John was a man. Both the statements would be expressed as man John because a fact wouldn't contain tense expressed in the sentence. John is grandfather of Jane. The purse is white. Over here the predicate name could be color and the item and the color of the item can be written, or if the different information about the item are shown but the information might not be homogeneous, in that case one can use item purse comma white. Here is information about a gadget, the laptop, the model, RAM, processor, price, etc. So these examples express that the number of arguments depend on the information expressed in the statement, and sometimes the statement might have some information which is extra and might not be part of the fact or rule whenever it's written. Here are certain guidelines. So if you have more information or similar information, then it should not be combined into one. For example, a comma in prologue is taken as logical and. So if you write a statement as Meera likes reading and Meera likes hiking, then that would be taken as a logical ending, and accordingly if you are talking about only reading as one of the hobby, then it will not be separated because it's logically ended over here. Similarly, writing all the interests of Meera in one predicate is also not a good idea because prologue is based on first order logic which follows matching, unification, etc. to give the answer. So some people might have two interests, some people might have only one interest, some people might have 10 interests. Thereby, every time you write a different number of arguments, that would be taken as a different kind of predicate and will not be used for matching even though some of the interests are matching. So the correct way of expressing this information would be write separate facts for each one of the interests. So Meera likes reading and Meera likes hiking would go as two separate statements. Now coming to rules. The rules express the relationships or logic generally written in terms of variables. For example, mother's brother is maternal uncle is true for every mother and brother of hers and all the children of that mother. So this is a general rule, and wherein whenever the information is replaced with constant values, one can state if the statement is true or false. So that's why rules are typically written with variables. Rules take the form of head and body, while head is the relationship that we are trying to define, while as body would contain one or more conditions under which the relationships are true. So here you can see the head will be true only if the body would be a tautology. Here's an example of when X could be mother of Y. So when X is a female and when she is also a parent of Y, in that case she would be a mother. So over here two facts are combined together with logical and whenever this is a tautology, then only mother X comma Y would be true. Here's another rule wherein if a person is married to another person, then the other person is also married to the first person. So here we need not have multiple rules could be combined on the RHS, but only one of them is enough to define the head. Third example expresses when we can define sister as a relationship. So when the first person is a female and the first person and the second person, they both share a parent, in that case, the X person is a sister of Y. So whenever female X, parent Z, X and parent Z, Y is a tautology, then and then only we can define that sister X, Y is true. Now coming to the data types in Prolog. In Prolog, we can use symbol as one of the data type. Can be used for person, items, etc. is general data type. When we work with numbers, integer, float are the data types that we can use. List is a data type which is like arrays that we have used in C, C++ and in other languages. String is a data type. Boolean is another data type which can take true or false as the values, and then there would be some free or anonymous variables. So in this example, X and Y are free variables, while as anonymous variables would be explained in the further slides. So free variable is a kind of variable which is not yet bound to a specific value during the execution of a query or rule. It can match with any value, and Prolog may assign it a value during the execution to satisfy the conditions of the query or the rule. Variables can be used for different rules in the same program. For example, if these three statements are part of the same program of the family tree expression, then we can see X and Y are the same variables used in different rules, and this is permitted in Prolog. Every time a statement would be executed, then the X and Y would have scope only for that statement or that rule. So once this mother X, Y is executed, then X and Y are free, and Prolog could use that to assign any other value which matches the given rules in the next statement. So again, mother X, Y would have a different scope, married X, Y would have a different scope, and sister X, Y would have a different scope. So these three statements to be part of a single program would be permitted in Prolog. So over here, these are free variables and they can take up values depending on the facts expressed, and accordingly they can go on finding values which are matching, and then they would define if the rule are true or false. So the free variables, they start with an uppercase letter or an underscore. So X would be a variable. Person, wherein P is capital, would be a variable. A variable starting with an underscore would be a variable. So these free variables, they act as a placeholder that Prolog will attempt to bind to values to satisfy the goals. And if they are left unbound, then Prolog considers them as free and may include it in the result of a query. So here are some examples of free variables. This is a program which contains three facts, no rules as of now. So Meera is a female, Arya is a female, and Meera is mother of Arya. So if I execute the program with a query that female X, then X is capital, that means it's a variable. Then Prolog would try to find out all the predicates which have female as the predicate name, has only one argument, and then it would give the values which are written in those predicates as the result for X. So X first would be Meera, then Arya, and the output would be given as two values which can be assigned to X, the free variable. Similarly, I can execute another query for the same program wherein I'm trying to find out who's mother of Arya. Again, Prolog will try to find all the predicates with the name mother. Then in that, the second argument has to be Arya, and the program would try to find out all the values for X, and over here, because it contains only three facts, X would have only one value, Meera. So this is how free variables are to be used and executed. Coming to anonymous variables, these are represented by an underscore. They are used when a value is needed for a condition but the specific value of that particular variable is irrelevant. This would be useful when we wish to ignore some parts of the predicates or argument that are not needed for the solution. So here is an example. How can we define if a novel is long? So the rule would be true when there is a novel written by somebody and has a title. The book has a title and the book has some length and the length is more than 300. So over here, we are interested in knowing which title is a long novel. So irrespective of the author name, whenever that title has some length and that length can be checked as more than 300 pages, then that title would be termed as long novel. So over here, the value of the author name is irrelevant. No matter whoever is the author, still the novel would be long novel or not depending on the page length, and that's why we use underscore or the anonymous variable for author name. Now let us look at a program, a complete program. So here's a program which is talking about some people and their interest. Here in Turbo Prolog, the name and sport are the entities which we are expressing in a predicate. So this increases readability and understandability of the program. And symbol is a general variable type which has been assigned for name and sport. So predicate indicates the relationship between the two entities which are bound together by likes as a relationship. So person's name is given and that person name likes the sport is the information expressed in the program. As we can see, domains, predicates, clauses are the titles of the sections and they are compulsory, while as in Swi-Prolog, the titles are not compulsory. We have not given here goal. That means every time we execute the program, we can write the goal in the execution section and accordingly we can go on executing different goals. So the program goes like this. Alan likes tennis, John likes football, Tom likes baseball, Eric likes swimming, Mark likes tennis, and Bill likes the activity if Tom likes the same activity. So as we can see over here, there could be more people who like tennis. There could be same person who likes more than one interest and so on. There's also a rule, activities A is capital. That means this is a free variable. In Turbo Prolog, we can separate head and body with if or a colon and hyphen, while as in Swi-Prolog, it does not accept if as a statement. So in Turbo Prolog, we can use if, colon and hyphen, while as in Swi-Prolog, we have to use this. So rules, how do we differentiate? So writing the rules, one has to figure out the difference between predicates and clauses, which is more important for writing Turbo Prolog programs. The predicate does not end with a period and expresses relationship between the variables which have been declared, and the clause would contain a definite information and that's why would have the constant values and would end with a period. Again, this is optional for Swi-Prolog. We'll see in the further slides the rules about capitalization and free variables which we have already discussed. Then grouping of the predicates and clauses, and in case if somebody would nest the predicates, then definitely the nesting of the predicates is discouraged in Prolog program. As we have seen, the capital letters are taken as variables. One should not use capital letter. One might habitually write the person's name with the first letter capital or city names with first letter capital, and then they would be taken as a free variable and the program would not give us the correct output. So Do remember to not to capitalize first letters of the arguments as they would be taken as free variables. Still, if you want to use the capital letters, then we may use quotes like the one expressed in this example, wherein Albert is in A as a capital. We can write it in the double quotes, and the EZY, wherein E is capital, letters are not so important. So over there we can use quotes and figure out if those should be taken as free variables or those should be taken as the constant values. About grouping, we have seen a small program wherein there were two females and a mother relationship was defined. So in a family tree or any program, there are going to be many clauses and many rules. So while writing the program, we should write all facts and the rules of a particular predicate together, followed by all facts and rules of another predicate. For example, in a family tree program, we should write the facts and rules related to person first together as one group, then write all the facts and rules about all the mothers about whom we want to write the information over there, then write all the facts and rules about the relationship father, then grandfather, etc. Do not write one fact of a person, then one fact about the mother, then one fact about the father, then one fact about the person, then mother, then father. So thereby the program would give us error and it will not surely execute properly. So let us see how do we execute Prolog programs. So here we have Swi-Prolog online compiler. We can go with program. So your Prolog rules and facts go over there. We have seen this earlier. We can execute the program over here. So how do we execute the program? We can fire different queries and we can get the answers for them. So how about I want to know all the interests of Ellen. So this is the way how I write the query. Any capital letter would be taken as a variable, and for that I would get the statement, click on run, and then P tennis is the only answer I have. What if I'm interested in knowing all the interest of all the people who are expressed in the program? Then I can use variables and accordingly I can get the answers. Okay. So this is how I can get all the answers. How about I write a rule over here? Likes. Let us say Tom likes P if Eric likes the same stuff. A full stop. And now run the program again and get all the answers for them. So earlier Tom did like baseball, and now Tom likes swimming as well because Eric likes swimming. You can execute any other program. Who can buy what? So if X is a person, Y is a car. If that person likes a car and the car is on sale, then the person can buy the car. At the same time, we have more predicates to go for. So a rule is written first in the program, while as the person information is given later. Then so rules first and the facts later is the structure of the program. As you can see, all people are written together, all cars are written together, all likings are written together, and information about things on sale are written together. So let us execute this program. I'll clear all these executions, earlier executions. And again, the program does not contain goal, so I can execute it the way I want. So how about I want to know what all cars are there in the information. So there are two cars, lemon and hot rod. Then who can buy what is another query that I can fire. Anything when I write in capital would be a free variable. So there's only one answer. Kelly can buy hot rod. In Turbo Prolog, you need not click on 10 or 100 results for the query. Instead, it would give you all the answers for the given free variables. So as you can see, the can buy statement would be executed whenever the body is a tautology wherein X is a person, Y is a car, X likes Y and Y is for sale. Now here we can see that Prolog takes backtracking as the approach. So when it has to resolve the answer for can by X, Y, it would start with the first clause in the rule, which is person X. So it would start with the first person. Then there is a match. It finds an answer for Kelly. Then it would go ahead with the second clause, which is car Y, and that it finds as car lemon. So X is Kelly and Y is lemon. With that, it would go with the third statement and will try to find all the matches wherein Kelly likes Kelly, lemon has to be true. So when we go to that section, the like predicate group section, we do not find Kelly, lemon is true. So what it does, it backtracks to the earlier step and finds out another value for Y, which is hot rod. Then it goes further and tries to find out if Kelly likes hot rod is true in any section. So this way, the Prolog uses backtracking for execution of the programs. Hope this video explains how to write and execute Prolog programs.